Hello guys, today I'm going to talk about this problem named partitioning the array. I have got this problem from the CP sheet of Priyansh Agrawal, TLE Eliminators. So in this problem, we are given an array of n elements, and for every divisor of n, let's say a divisor is k. Um, we have to divide the array into n by k subarrays of length k, and we earn a point if there is a positive integer m, and if we take modulo of each elements of the subarrays of each subarray by m, and then after taking the modulo, if the uh, subarrays are identical, that means if the subarrays are same, then we get a point. So we have to actually tell the total number of points, the number of points ln will earn. So if I boil down the problem, then uh, there is a n, there is an array of n elements, and we have to divide the array into some subarrays, right? So and there are obviously there are some divisor of n. For example, one of the divisor is k, so we have to divide the array into n by k subarrays of k elements. So we have to divide the array like this subarrays, and if there is a positive integer m, and if we take modulo of each number by m, and after then if the subarrays are identical, then we get a point, right? So if we take an example, for example 62622, so 6 6 okay, um okay, I just write it down. 626 uh triple two triple two, and for example, here n is 6, and if we take the divisor, for example 2, let's see if it is no, okay, if we say 2, then the Sabere length will be 2, right? And if we take the m as 2, then it will be 0, it will be 0, it will be 0 0 0 0, and we can be sure that the subarrays are identical. So we have to find such numbers. We have to actually find how many divisors are actually how many divisors are there for which we are getting an m, right? So the thing is that we actually know the maximum answer of this problem, which is the number of divisors of n. Now, mm, if we somehow tell that for a particular divisor there is a m, then we can actually increase our answer, right? So we are actually thinking about getting an m for a particular divisor, right? So for example, if k is equals to 2, that means after taking modulo m, these elements and these elements has to be same. So if we take this element as x, and if we take these elements and y, how can we are sure that after taking modulo m in both numbers they will be same? So if we just take the difference between them, x and y, so to be able to be same after taking modulo m, the difference of these numbers, of these two numbers, has to be divisible by m, right? If we take if I actually explain this using mathematical notation, it will be like x modulo m has to be y modulo m, right? And if we just shift the y here, x minus y modulo m is equals to y modulo m. So we are sure that this x minus y, the difference between these two numbers, it has to be a multiple of m, or the values of m has to be a divisor of the difference of these two elements. So we are actually we are actually getting a set of m, set of values of m, right? So we have to fix an m. So if we take the next index, we have to make sure that this index and this index, after taking the modulo of these numbers, the numbers have to be identical for a particular m. Now what I have done is that um, for these two subarrays, I have taken the differences of the indexes, right? I have taken the differences of the indexes. For example, the difference of first two index is d1, that is difference of second indexes is d2, right? Then I have calculated the greatest common divisor of the differences, and I've gotten a number, a possible m, for example m1. Then I have checked for second and third subarrays in the same way and get another m, and so and so on. I've possibly get some n, right? um k minus 1, n by k minus 1. So these are my possible m's, and to satisfy all the subarrays, so that all the subarrays are identical, there has to be a fixed m, and these are these are the divisor of the differences, right? Now if I take the divisor of these m's, if I take the greatest common divisor of these m's, then I can find the actual m, and this m has to be not is equals to 1, right? This has have to be not is equals to 1, because if it is equals to 1, then there is no m, right? So I think you have gotten you will get the you have gotten an overview, but you will get the actual perception if I show you the code. Here I have taken n as input. Then what I have done is I've taken the divisors of n, and for each divisor, um, what I have said is first two subarray, right? I am taking the first two subarray, so I am checking here the first two subarrays indexes. So and I am taking the differences of these indexes, and I am calculating the greatest common divisors of the differences, and I am pushing the uh, greatest common divisors of differences into a vector, then again here I've said that I have some possible m's, and from these possible m's I have to take the GCD again, so that I got a fixed m, so that I can get a fixed m, and that's why I have taken the GCD of the possible m's here. And if it is not is equals to 1, oh, here there is another thing to explain. For example, I've got a possible m for I've got a possible m for a particular divisor k is equals to 2. Then we are sure that for k is equals to 2, the subarrays are identical. If for k is equals to 2, the subarrays are identical, then the multiple of this k, for example, k is equals to 4, and if it is a divisor of n, right, the multiple of this k, and if it is a divisor of n, for this k, for this new k, I actually don't have to check whether there is a possible valid m, because it is actually already proven for k is equals to 2. Because if I get a possible m for k is equals to 2, I'll also get a possible m for k is equals to 4, right? So that's why I am actually um, iterating through the multiples of these divisors, and if this multiple is the divisor of n, here I am checking whether it is the divisor of n, and it is actually not found, then I am actually increasing my answer. So here this problem is actually very good problem, as here the main fundamental thing um, is to check whether there is a possible m for a k. If we get this idea, I think this problem is actually very easy. If we get this idea that how to check whether there is a possible m for a particular k. So if you have any question or suggestion for me, you can put it in the comment box below, and hopefully I'll keep up with you in the next video. Thanks.